the last in our Webinar Wednesday series. So if you haven't been to one already, welcome. If you have, you might recognize the format but not the content. So essentially the Webinar Wednesday series of webinars has been run under the Connected Programme in Northern Ireland, which is a programme funded by DFE to help stimulate collaboration and economic growth locally, but it's really about facilitating collaboration between the university and college networks in Northern Ireland to deliver knowledge transfer and sort of skills sessions, a bit like today's machine learning focused session throughout the academic year. So Belfast Met focus on a range of areas including emerging technologies and new product development. So we've had webinars over the last number of weeks in things like Power BI dashboards, blockchain, new product development, design thinking, and through to like human-centered approach to the sort of COVID-19 pandemic. So Martin Naughton today is going to take us through a real introduction to machine learning for SMEs, but really for anyone who's wanting to know what the heck is machine learning, what does it do, what can it do, how does it work, in real simple terms. So Martin's going to take us through that in sort of around 25-30 minutes. Try and keep it short and sweet. But as I said, if any questions crop up or there's something that Martin's talking about that you want more clarity around, drop a message into the chat function here and I'll collect those questions at the end, and we can have a bit of a 5-10 minute Q&A at the end. But I'll pass you over to Martin to take us through this session.
Cool, thanks for that, David. Yeah, so I'm just going to do a presentation, take about 25 minutes there. So it's just an introduction to machine learning. So this is really, really, really simple. So it's again for nobody that knows about machine learning or has heard a lot of hype about machine learning. It's kind of for aimed at that kind of audience there, because I find a lot of people do come to me asking about machine learning or what can it do, but they're very vague. And I think sometimes people want to apply machine learning to their problem before they actually have a need for it. So it's kind of to help you understand what it can do and what it can't do as well, and how you should approach the machine learning, introducing machine learning into your application or into your business and stuff. So yeah, so just on a really high level, what machine learning is. If you think of it, it's the use of generic algorithms to create, to look at data and to learn from data and train itself. So what we have in machine learning is what we call models, and models represent models represent what the machine has learned in the system. So it's like we can train a machine learning algorithm to understand what a cat is in the picture, and if we give it enough data, it can understand then and pick out a cat in the picture, or if there's a cat in the picture. So again, it's all about data. So the machine doesn't know these algorithms at the start don't understand anything until you train it with the data. So you can think of it like a child. A child when it's very young doesn't know how to read, but once you give it more, train it using books, the more books you give it, the more it starts to understand how to read then. And before long then it can just read itself. So think of it like that. Machines as well, they need lots of data. A lot of people come to me and they have an idea for a machine learning model, but they don't have the data. So you've got to have the data to train it before the machine becomes smart. Machines are dumb by nature at the start until you train it to do a certain task as well. So we have multiple algorithms that we can use, but what we really want to understand is the problem that we're facing and what algorithms we should use then as well first. So a lot of we have machine learning in loads of our applications. Today it's become the norm. I just even remember maybe 10 years ago, Facebook didn't have facial recognition detection, and they were looking into that. Now they can tell who's in the picture, if you're in the picture, who else is in the picture, based on training. So you put up a lot of pictures, it can then train itself then to recognize you in all the pictures then that you haven't tagged. So that's a kind of mainstream thing that we have now, and especially in cameras now or on our phone. They use machine learning models then to recognize faces. So now they can tell who's, where the people are in the picture there, or they can put a circle around your face then, so they can recognize where the face is in the picture. So that's become mainstream then as well. So there's other places, and I think in the next 10 years it'll become a lot more things that are not mainstream today, it will become more mainstream. Like, so a lot of social media companies as well are using machine learning to kind of do targeted advertising. So they take in a lot of data, train it on that data, and then they're able to target them. Like, so, but also they use it as well to delete offensive comments as well. So they can train machine learning models to say what is an offensive comment, and then when the machine can then go scan in the social media pages then and delete kind of what it thinks is offensive comments. So again, it's kind of learning, if you think of it like that, is training a model to do a certain task. Again, like if you're thinking about it, when you're starting a new job, you have to be trained up how to do that job. Like, so you need data, if you think about it, to do that training as well. So yeah, so that's kind of thing. So again, you got to think of it as patterns and rules. That's what the machine is looking for. It's looking for a pattern or rules in the data, because then it can come up with like either an algorithm itself or a function that kind of like, if it puts in this data, this should be the outcome. So that's what it's looking for within the data and how you train it. Like, so yeah, so kind of if you think about it as well, it's problems you might solve with machine learning. So think of it like that. Machine learning can't do everything today yet. Maybe in the future we'll be able to do everything, but you might have a problem where you need to extract information from text. So again, I remember my friend telling me, he was in Australia a good few years ago and stuff, and there'd be data entry kind of people. They would read stuff from a sheet, and then they would then enter in data into a database then, and that's how he kind of made his living there when he was in Australia actually. So again, now there's machine learning models that can actually extract that information out of a picture now for you and put it into a database. So even if it's handwritten, that can be done now. So that's a lot mainstream there. Like, so other problems you might do is predict between several categories or predict between two categories. What you're doing there is really classification. So you might want to predict if this picture should be in a group of cats or in a group of dogs. So it's kind of prediction as well. You can generate recommendations as well, like Amazon and all the big e-commerce companies as well are using that to kind of to generate recommendations, like YouTube. Now when you go to YouTube, it's based on your usage and based on how it's trained, based on other people's data as well, on what kind of songs or videos you'll like to kind of look at as well. And then a classification, classify images as well. That predict and classify are different. You might want to classify images based on what's in the image as well. Now I heard this maybe 2 years ago that insurance companies were looking at, like, say if you had an accident, you would take a picture of your what happened to the accident. They could use kind of machine learning models that were trained on looking at car accidents, and what you would then do is upload it, and then you would be able to get your be compensated then for if it was not your fault, then to get the money back for fixing the car or how bad the car was. So again, they're using machine learning models to kind of tell how bad an accident is as well. Like, so, and so you can classify images, and you can classify images in a lot of different ways. And as well, predicting or forecasting values in the future. Again, that's like basic statistics. You've got a bunch of data in the past, and let's try and predict the future based on that past data. So you might want to do predictions. You might want to do predictions based on inventory usage in the past, and you're like, predict in the future these much inventory I'll need. So kind of McDonald's or Burger King can kind of use that to kind of like predict. And also they can take in other variables, like not just the inventory, but how many people were in the place at the time, and they can do better predictions as well. Like, so these are the kind of problems you might solve, like classification, predictions, extract information from certain places as well. So that's the kind of thing. So they're the kind of problems you might solve. Then we have different types of machine learning. So we can categorize machine learning to, like, on a high level, into 3 different things. We have supervised learning, unsupervised learning, and then reinforcement learning. So supervised learning is when you're training a machine learning model then based on your data. So you're giving it the data and you're saying, these are the inputs and this is the output I expect for this data. So you're training it so it can look through a lot of data, and then you've trained it exactly. So think of it like fraud detection. There you might have a list of details of fraud that happened and when fraud didn't happen, and then what the output was, like fraud or not fraud. Now you can give that to a machine learning model, then it can train itself then to kind of identify those kind of different types of fraud. Now fraud, say in my company, is different to a fraud in a different company. So that's why you want to use supervised machine learning there to kind of classify that, because unsupervised machine learning doesn't know how to put the output. You have to give it that output. There it can kind of predict it. So kind of supervised machine learning is what is the kind of first one a lot of people will kind of understand, and it's easy. And we'll go through one example in a minute. And then we have the unsupervised machine learning, where you give it the data and it gives you the predictions or the classifications based on what it knows itself. And then reinforcement learning is you are training the model, and then the model comes back and it says, this is the answer, but then you say, yes, that is the answer, or no, that is not the answer. Then it goes back and trains itself. So it's kind of reinforcement learning. And again, you can think of it like a child. Child is learning to read, and the child reads the word wrong. Then you tell the child, actually, no, this is how you say it. You're reinforcing into that child how to learn. So that's kind of reinforcement learning then. So there's kind of 3 levels, high levels of the different types of machine learning. And then you have just the algorithms and kind of the ways you can use it within those categories. You have kind of classification there. So you have kind of fraud detection, email spam detection. Like email spam detection is the norm these days. It's very normal to have that. We have it in all our email clients. So it's, and they're kind of trained on how to tell if an email is spam or not spam. So it has 2 outputs. It just has spam, not spam, and it's trained on lots of data then. Like, so what it's looking for is certain features within the data, diagnostic and image classification as well. Like, so we can classify all images as well. So we got regression then kind of predicting as well. So then on supervised learning, then we got like text mining and facial recognition, big data. So that's when we kind of use that kind of more unsupervised learning there, is kind of with dimension reduction. And then we have clustering as well. So again, we're just going to really go on the supervised learning, but you can kind of tell the difference on a high level between the 3 of them, like supervised learning and unsupervised learning there. So yeah, so that's that kind of thing. So what we'll do is we'll just do a really simple, see with the unsupervised learning and maybe reinforcement learning, sometimes you can't tell how it's come to that conclusion. You just kind of, you have to tell it. But with supervised learning, you are training it, and it should come out with the outcome that you expect. So we'll kind of do what we call a decision tree. So algorithm. So this is the most simplest algorithm that we can understand as humans. That are, if anybody starts to learn machine learning, you kind of start with decision tree, because decision trees are something that in what we do in our minds every day is happening. So we're constantly making decisions there. If you think we go to the coffee shop, we're deciding based on the cost of the coffee, which coffee we're maybe going to get. Or so if the coffee's £3, I might say, geez, I'm not going to pay £3 for a coffee, where someone else might do. So again, we're making decisions throughout the whole day on that. So this is what a machine can learn as well to do based on features. So what we kind of show here is a simple decision tree. So again, what we have here on the left-hand side is just a data set, what we call a training data set or a rule set. So what we want to do is use this training data set to train our own model to identify when it is, what species it is. Is it a mammal or a reptile? So this is our training data. So think of it as well, like, yeah, just like that. Like, so we have 4 features if you think about it. We have tooth, hair, breeds, and legs. So they're the 4 what we call in machine learning features. So you have to identify features of the data And then what we have is labeling. It's just species then. So we say the label is, this is the output it should kind of produce. So if you have a look at this now, it's only 10 rows long, and it's 4 features that we have. See if you can figure out what information, what should be the output. Do you know, is it always true that the mammal is, or is it true, is it false true that the mammal is? Again, the machine can see a pattern in this, what we might take a while to kind of figure out. So, so have just a quick look at that there. Let's see if you can figure it out. So again, it might take you a bit of time to do this, but if you thought about this, is I can use this as a programmer, I can make a program that kind of start to identify, like, based on this rule set, but identify if the mammal is reptile or this species is mammal or reptile. So what I would normally do as a programmer is kind of make this logical flow of if and else statements then. So if it's tooth, then and true, and hair, and breeds and legs, I would say mammal and stuff, and I would have a lot of rules kind of in that. So what we really want to do here is, because this data is only 10, but maybe we have 20 or 30 or 40 lines of training data. You know, it takes the programmer a longer time to kind of figure it out, or maybe there's more columns, so the programmer has to kind of figure out those patterns. What we could do instead, like, is use a machine learning simple decision tree to kind of give it the data, and it can tell us then what's the logical flow, and we can use that program then. So what we might do is we'll use this training data, and every day then we might get 100 rows of data based on the species, and we want to figure out what they are, like, you know, so we want a program to have to do that. But what we can use then is a machine learning decision tree to kind of automate that for us. So what you can see, yeah, so what we can do there. So again, with using machine learning compared to a programmer doing this, is if the amount of columns starts to increase. So say the programmer does this today and it does for 4 columns or 4 features, but then later on, 2 weeks later, the company comes around and goes, actually, we have 10 features now. We need to update that program. So the programmer's got to go through, identify the rules and the patterns in it, update his program. So it's taken him a lot of time to kind of do this. With a simple decision tree, then we can just point out the data and it can kind of figure it out for us. And then once it figures it out for us, it makes a program for us that we can use there. So we're thinking about scalability as well. And if you still haven't found it out, we'll go on to the next slide. And the machine learning model has figured it out for us. So I just gave, so I used a bit of Python here, and I gave the Python program, it has a simple decision tree algorithm there. I just gave it that 10 rows of training data, and I said, will you figure out what's the strongest features that correlate to the output? And what it's found here is if hair is 0, then it's true. And what it said is it's a reptile. So there's the reptiles don't have any hair. And then if the hair is false, then yeah, I always get confused on this one. Is hair false true? Yeah. So what it's just done there has figured out the decision tree for us there based on hair. So if we go back here, we can actually figure out if there's hair is true, then it's a mammal. But then if it's false, it's a reptile. So this column here, or this feature, is strongly correlated between hair and species, is strongly correlated. It doesn't really matter if it's tooth, breeds, or legs. It's the hair that really makes it is the pattern there for it. And again, what it's done here is, like, you can use this in Python. It can print out the decision tree that it's designed and that it's programmed to, and we can exactly see what the machine learning model is trained on as well. So again, we can use this program then to consistently then output our decision for us. Again, as if this information becomes more and more, we get more and more columns, then we can just point out the Python program can point out the data and train it again. As long as there's a pattern, if there's irrational patterns all over the place, it will be just strongly correlated to the data. So it's got to be some kind of pattern then. So again, the machine learning model can tell us if there's a pattern or not as well, which is handy. So again, this is just a picture, and you just kind of output it from Python then for yourself. So again, this is what it's correlated to then is, as you can see, this is what the actual Python converts it to. So it sees true and false, and what it converts it to is ones and zeros for itself. So what you can see there is hair, when hair is 1, species is 0. So 0 is for mammal. So when there's hair, it's a mammal. So, and then when it's 0, when there's no hair, then it's a reptile. So this is what the machine really converts it to itself, like so. There. So again, you've just seen a very simple example there of how to do a decision tree and kind of what kind of training data you need for that. Again, in the world, we have a lot of unstructured data and not machine readable data. So we have to convert it to this, for ourselves. So again, it's just how to kind of approach these kind of machine learning problems. Again, a lot of people come to me and say they have an application, they have machine learning, it's just such a generic term. And they should maybe like, say exactly what the machine is doing. Is it doing predictions or classifications? So if you want, and you're thinking of bringing machine learning into your application or into your business, be thinking what are you actually going to use it for? Instead of saying, I want to bring machine learning in, what is the problem you're trying to solve that it can solve? It can't solve everything for you. It could do predictions, it could do classification, it could do text extraction for you. So think of it like that. First, identify the problem. Then the biggest thing that you have to do is get the data into a machine readable format. So that's a lot of data scientists spend a lot of their time just getting into a format that's machine readable. Again, it could be in Word documents, PDFs, that's where you're getting your data from. And that takes a while then for somebody to convert to machine readable format the machine can understand. So that takes a while. So you spend a lot of time doing a lot of work before you get to actual machine learning. And another bit you have to kind of do with supervised machine learning is you have to annotate or label your data. So the way I had, like, if it was reptile, if it was mammal, or if it was reptile, I had to go around doing that myself, creating that, labeling data. Now you might have labeling data, or you might have data there they have to go through and label. Now you can get companies to kind of go off and do that for you, do that labeling data, which then becomes training data for your algorithms, so you can spend less time on them, so you can hire them in foreign countries to kind of do that for you. So, but one thing you have to kind of tell them is what features out of that data you want to get out. The way I picked out 4 pieces of information about an animal or about a species that I wanted to define, if it was a mammal or if it was a reptile, I could have more and more features if I wanted, but it's me to decide that, that kind of way. So it's what it's called there in machine learning is kind of feature engineering, is picking out the features that make the most sense to kind of use to generate your output there. And then you spend a bit of time then applying the appropriate algorithms to the data to get the desired output. Again, they're all generic. Some algorithms are good at classification, they're not good at prediction. So you kind of have to find that out, or know somebody that knows these kind of issues with these algorithms. Again, they're coming out with algorithms all the time, and some are getting better and some are just the same. So think of it like that as well. So you have to spend. So there's a lot to machine learning instead of with some of this stuff, like so. But yeah, so that's on a basic level of you doing the actual machine learning yourself. So again, you got to be wary. You need data. A lot of people come to me and they don't have any data for machine learning. They have an idea, but that's the one thing you have to go out and get is the data. Without data, we can't have machine learning. There, we can make up dummy data. I'm not a big fan of making some dummy data. If you're thinking about machine learning model, it's good to get real life data out there. Like, so it's, again, just think of it like if we don't have data, it's like starting a new job. You need as much data as you possibly can to do the job properly. So, and again, we have a lot of unstructured, low quality data out there. Making it machine readable is, high quality. So again, think about where your data is coming from, or if you can get the data. This is How to Train Your Dragon. I think that's a picture from it there. So think about it there. I brought you through, you had to do the actual training of the model. You had to give it the data and stuff like that. It's very cumbersome. And, if you're in a business, maybe you're like, this is not for me, but there's other, and you're starting from scratch as well. I have a species detection model there, and it just, it decides what species it is there for me. Now, if you think about it, not everybody starts from scratch there. You can get models out there that maybe do that already for you, and you just add more data on top of it. So you can get machine learning models out there that can identify animals, or can identify cats or dogs, and but you can kind of build on top of that model, and you can add your own data in and train it more. Think of it like a child in primary school. They learn to read at a certain level, but then you bring them to secondary school, they learn to a higher level. Think of it like that. You can bring them the machine learning model to a more confined and focused learning on it. So you don't have to train your own model. There's existing models out there already. So I don't know if you probably see this. There's this Model Zoo, and what it is, just a GitHub link there. And what it has a bunch of machine learning models that are already built. So you have image classification ones, the different ones that are there. There's ones done by Google. There you can take that model down, you can run it yourself, and it can identify it there. So again, we wouldn't start from scratch myself, unless your machine learning, the problem you're trying to solve in machine learning is very specific, or so. So that's the kind of, again, be thinking about that, is there models out there that can do it for me? We're starting a new machine learning project there. We're probably going to use existing machine learning models that are already out there. So so that kind of thing. So there's, again, you're probably thinking, geez, I have to download machine learning models, run them myself and stuff. And you might go, this is not applicable to me. It's not part of my business. Another level you can think of it then is the cloud services. Now, they're getting very specific to machine learning. So they have services that you can use. So you don't have to do the training of the model. It's already done for you. You just have to give it, or you could have, so it's already done for you. So you don't have to train a machine learning model to do text extraction for you. They already have that there for you. So you just kind of give it data and it can do text extraction. So Amazon's probably the top one at the moment for kind of those AI services, they call it. So they've kind of got APIs that you can send data to, and it'll give you the answer back and the data back that you want. So we've got Amazon recognition there. So it can spot people within a picture. So what you can do is upload a bunch of pictures of people you want to identify and to train it. So you just upload it, it trains it, and then you give it the actual data that you want to start sifting through to kind of identify people. So it's already done that. All you have to do is give it the training data. It kind of does everything for you after that, and you just call an API. There's kind of as well Amazon Text Track then. It's already trained on how to look at images with text in them and extract the data out. So you don't have to train a model on that. So it's already there. So again, all the downside of it is there's the cost associated. Again, you just have to see if the cost of using these services outweighs the getting the model, training the model, testing the model, all those kind of extra pieces of work that you have to kind of do. So you have to check between the two. So you've got Amazon forecasting as well. You can just upload the data of previous data, and then it can do the forecasting for you. So again, it's all these services that are available for you. Now you can use Amazon ML services if you're like, actually none of these APIs do exactly what I want. I'll make my own machine learning model. I'll train it. I have the data and stuff. You have these ML services. So you got Amazon SageMaker that you can upload models to and use their infrastructure to kind of train your models as well. So yeah, so you got those two different levels as well. So I think Amazon's going to keep going with these kind of AI services. They'll kind of do very specific AI services in the future that, you know, are kind of becoming mainstream then, so you don't have to train any models like so. Yeah, so be thinking of those levels. So I kind of brought you through kind of 3 levels, just towards the end of, like, you know, doing your own machine learning model there from scratch, you know, using other people's machine learning models and improving them, and then just using API services that already do exactly maybe what you don't want to do. So think about it where you want to spend your money, you know, and see where, if the problem is solved with these AI services already. If they are, then I would go use those myself. I use some of them without going ever training the machine learning models. So like Textract, I use that a lot. So don't have to do that. So if there's any questions, I think David will go on talk about some stuff about different programs that can be useful for your business. Maybe you're thinking after this, okay, maybe I need to sit down and see if machine learning is applicable for my business. Like, you know, there's a lot of ways the Belfast Met can really help you. And being from Galway, you definitely don't have that help down in Galway. You definitely have a lot of help up here to help your business understand before you invest. Like, you don't have to pay any money. So I think that's quite good. So David, yeah.
Yeah, brilliant. Thanks very much, Martin, for taking us out whistle-stop tour on sort of intro level machine learning. We have had a few, well, say quite a few questions coming through. So I'll just grab a few and put them through to you. So I think you might have already covered this, but we had a question that asking, are there off-the-shelf solutions for building models? I think you sort of stepped through the Amazon services on that side of things, but obviously there's, you know, probably a bunch more out there that are
you've got the different Google, and you got Azure, Microsoft Azure. They have that services for building your own machine learning models. One thing as well I probably forgot to say is there's a cost to building your own model. The cost is your time and the electricity cost of the computers. So you have to be thinking about that as well. Machine learning models are not free. They're not free on Amazon, but they're also not free to make it yourself. So, but you can use their ML services to, you know, the Amazon ML services to kind of probably build them faster than your own laptop, say. Like so.
Brilliant. You just answered the next question, was what are the costs for getting a model to run on my data? But I suppose that's, you know, sort of a bit of finger in the air in terms of, you know, you can't really calculate that from the get-go.
Yeah, it depends on the size of your data that you have. You know, if you have a small amount of data, maybe you can, you know, it's a lower cost. It's really the size of your data. If you have gigs and gigs of data that it has to be trained on, you know, it's going to take a while for the machine learning model to understand that. So it's going to take a while to train. So
perfect. Next question was, which application of machine learning have you seen SMEs in Ireland adopt and get real value from?
Textract. I think extracting data from images. You know, instead of kind of doing it like I was talking about my friend in Australia doing that kind of doing that data input. You know, they can use Textract, and what they do is they just upload. They can upload all the PDFs that they have and extract the information out of them pretty fast. There, so you don't have to pay someone manually to do that, and you've got speed as well, like and predictability. So I've seen a good few companies start to use that Textract there. So other ones is Axial 3D. Axial 3D use machine learning models there for building you know, hip replacements and stuff, and identifying like issues within bone structures and stuff like that. So they're quite a big Northern Ireland company to kind of do a lot of machine learning there. So I think it's just going to be more and more apparent as we go along that more machine learning will be used. Actually as well, probably it's not a company in Ireland, but it's a company in Limerick now, and they've got now a door since COVID-19 has happened. It will only open now if they detect you don't have COVID-19 and they're basing on your temperature. So they're using a lot of machine learning there for detecting people, but also like your temperature based, so and other features about you maybe when you're walking towards the door. So they're going to be quite big, I think, you know. So you can't get into a building if you have COVID-19. So.
And then I think probably the last question here is, if someone presented you a database of product units, prices and sales transaction for a business, that wanted to get value from that historical data, where would you start, and how would you visualize the findings in an easy to understand format for the business owner?
So what you probably want to do is predictions there, I'm guessing, Dave? So
yeah, they're just asking how do you extract value from the historical data. So it's probably
yeah, you could do stuff where maybe there's a correlation between certain features in your sales and the output of your sales as well. You can kind of have a look for those patterns, because within historical data, there might be a pattern. Now, it might take you as a person to kind of look at that information and go, there's a correlation in between, the start of the month and how much money I make. Machine learning models can identify those patterns as well for us. So that's quite good. And yeah, you can use charts as well. But yeah, sales forecasting is a big one as well. That's probably doing predictions as well. So the first thing I talked about was kind of recognizing patterns in your historic data, but also doing predictions in the future then based on your historic data.
I think that wraps up. We probably could go all day with some of the questions coming through, but if anyone has any other questions, feel free to drop me an email after the session and we can have a chat. And I suppose I realized at the top of the session, I didn't actually properly introduce myself. So I'll do it the wrong way around, but my name is David Phelan and I work for Belfast Met College, and as Martin has touched on, I work for, that's a bit of a mouthful, the Centre for Economic Development and Social Inclusion team. But essentially my role is to connect the dots between industry and academia through some programs where we can offer funded or partially funded support to mainly the SME sector, so companies with under 250 staff or under 50 staff as well. So just to give you a few of the sort of highlights of some of the programs that we run and can offer support under. So Connected, which today's webinar has been sponsored by, is a fund provided by DFE to help, as I said at the top, universities and colleges collaborate more closely with industry in terms of knowledge sharing. And I suppose based on what Martin's been discussing today, if you do have questions about could machine learning help with my issue or my problem, or is it something that you could tap into for your business, we can potentially offer support and guidance under Connected, fully funded. Just in terms of what Martin touched on, instead of you deep diving into sort of potentially pumping resources and money into machine learning, we can help you sort of flush out your idea or your issue and see if machine learning is the right fit or is the right solution, or is, what part of AI machine learning might be the right fit for that. So that's something to consider under Connected. Within Innovate Us program, that's really about one-to-one technical mentoring. So your company or business being paired up with a lecturer within the college to really provide tailored upskilling and training. So it's not about a qualification or a course, it's really honed in on an area that you have an issue or a problem with, or something you want to learn to help drive your business forward, linked to developing either a new product, service, or internal process. So again, if something you are potentially dabbling in machine learning or AI at the minute, but you could do with more guidance and training on through in a one-to-one way, that's something we can look to fund fully through Innovate Us. Another area that we can assist in machine learning or AI in is innovation vouchers. So that's really about if you have a brilliant idea that machine learning could be the answer to, but you don't know how to do it, you're not technical, but you have a brilliant idea and a brilliant solution. Innovation voucher can help fund a university or college develop a prototype or proof of concept for you. So it's that real starting stage of your potentially a new business or a new service line within your business. Or you might not be a business, you just could be sitting at home during lockdown, you've had stacks of brilliant ideas about new products or new services. Innovation voucher scheme run by BestNI is perfect for that. I think the next call, so there's generally 4 calls a year to apply for that. That should be coming out in about two months' time. And that's something the college can even help you with your application to really hone your application and think about if you were awarded the voucher, where you might spend, not that you don't get £5,000 in your hand, but where you might use that funding, and how you might best use that £5,000. That's something we can pair you up with a lecture, and that's your specific area of interest, and help you with that application, and then potentially be lined up to help deliver that for you as well. And that's one of the programs that Martin would be heavily involved in, sort of developing those initial proof of concepts, prototypes for companies and businesses. And then, so last but not least, skills focused is actually more focused on proper full-blown qualifications and courses, certifications. So over the summer, we've been running a range of Institute of Leadership Management courses, cybersecurity courses, and even into sort of digital design within construction and BIM courses as well. But we'll be launching a fresh set of courses starting in August, September time. So ordinarily, DFE fund those up to 75% for companies with under 250 staff, but due to the coronavirus pandemic, they're actually funding that up to 100%. So fully funded courses or qualifications for your staff if you do have under 250 staff. So a really great area to look at sort of continuous professional development for your staff, and pretty much all of those courses are being delivered online as well. So you can continue to learn from home if you're currently furloughed or your workplace isn't open up for a while. You can undertake those courses from home. And really that probably just leads me to say, in terms of any of the information, I will drop that out to you on email after the session, including Martin's slides. But if you want to follow us on Twitter, the CEDSI team have their own Twitter, which is at E3_BelfastMet. So that's where we'll share a lot of our information in terms of these programs and calls and areas of support we can offer, as well as any upcoming webinars. So this is the last in our series of webinars that have started over the summer, but later on in the year we probably will roll out more in the areas of emerging technology and new product development. But if anything is of interest, or you just want to have a conversation, you're not sure, you might feel like you need some support, but you're not sure how we might do that, it's always just worth a conversation. So definitely drop us a message either to our main inbox, which is cedsi@belfastmet.ac.uk, or when I send out the slides, feel free to respond to me, and we can get chatting and see how we might best support you. But thanks to Martin again for taking us through this session today. Hopefully you're more enlightened about what machine learning is, and you can sort of chat in a bit more depth with colleagues and clients, etc. about that. And see you all again soon. Thanks very much. Bye.